Hello, I'm back and we're talking about marginal rate of substitution. Last video, we spoke about indifference curves, consumer preferences, and behavior. So, like I said, I'm going to speak about substitution. So, we spoke about indifference curves, like I said, and we spoke about the willingness to substitute, but that's not the proper word. The word is the marginal rate of substitution, which I abbreviated to MRS, which is the maximum amount of one good a consumer is willing to substitute in exchange for another additional unit of another good, and it keeps the same utility. Now, if we look at this little curve over here, we can see at point A we have 5y 10x, but at point B we have 2y 12x. Okay, so now the formula for the MRS is actually minus change in y divided by change in x. Now, this is pretty easy. We're going from point A to point B, so that'd be 5 minus 2 divided by 10 minus 12, and we put the minus at the outside, and that'll become 3 over 2. Now, the thing you gotta understand is with at least regular convex and difference curves, the MRS is, you can see the gradient is not the same everywhere, but it's convex, it's sloping downward. So, just because from point A to point B, the MRS is 3 over 2, that doesn't mean that's going to be the same for all points on the curve. That's actually, we're going to get to that a little later. So, imagine we had a utility function of u is equal to x, y. Okay, that's pretty cool. But now to truly plot this on an indifference curve, we have to make y the subject. So, of course, to do that, we'll just divide both sides by x. U over x is equal to y. And then if you want to find the MRS at a point on the curve, then that would just be the partial derivative of u divided by the partial derivative of x. Another important thing I got to mention is, we know the formula. It's the minus change in y divided by change in x. So that would mean that in a regular convex curve at a point, you'll see that sloping downward like this. Now, that means that the further down we go, the lower the MRS becomes, because we are less willing to give up y in change of x. For example, over here, let's just say beyond b, right? We have, of course, 2y 12x. But now what if we kept moving? What would that look like? It would kind of slope downward and it would become like a straight line, wouldn't it? So that means we're less willing to give up y in terms to change or to substitute x. But as we move up the curve, like this point over here, like beyond a, let's just say, that means that even if we get to 6, 7, 8y, we're still not willing to give up 9, 8 of x. And this is actually a normal kind of consumer behavior. So if I plot a different curve over here, if I put it over here, 1 second. Yeah, so consumers would actually prefer to be in the middle. They don't want to be at point A, because at point A you have a lot of x's, but not a lot of y. And at point B you have too much y and too little x. So you'd rather be at a point like C. It's a little more unitary, it's a little more balanced. That's why we say in the middle. So that's why the MRS, when it goes further from the origin at a convex curve, that means the MRS is falling. But if we go upwards, like toward B and beyond, that would mean that the MRS is rising, because as you can see, we're giving up more y for a little bit of x. But over here, we're giving up a lot of x for a little bit of y. And if you use the formula, mathematically you plug it in, you'll see. So now, I mentioned that the gradient is not constant for all points of the indifference curve. This is where we get into perfect substitutes. Now, as you can see, if let's just say juice. Juice is a good example. So juice, you got apple juice, orange juice, pineapple juice. They're all relatively the same thing. They're not rare. They're probably the same price. So you would substitute the same amount of one good for another. Let's just say the ratio is 1 to 1, right? I'm willing to give up one apple juice to get an additional unit of orange juice. Okay, and by the way, this is the same throughout, and they give the same level of utility, which is obviously the main point in these indifference curves, which is why it's always constant, because they're perfect substitutes, because they give the same amount of utility. No matter how much more we get of one, it's going to be constant. It's going to be the same gradient. compared to perfect compliments. Perfect compliments requires that consumers get them at specified quantities. For example, shoes. Do you just buy a right shoe? No, you don't. You go to the store, you buy 2 shoes. You buy 1 left shoe, 1 right shoe. And we often just call that a pair of shoes. So you won't just buy a left shoe. You won't just buy a right shoe at different points. No, you will always buy them together. That's why they're complements. And these are perfect complements. As you can see, the gradient is either 0 when it's perfectly vertical, or it's infinity when it's perfectly horizontal like this. And for these curves, actually, you can keep going. So like I said, in the last video, there are indifferent curves for any level of utility. So that means it'll look like this. There's always just fucking hell, man. There's always just right angles being created. I don't want to cover the board actually. Here, yeah, see? Right angles being created. Same thing for the perfect complements. Perfect substitute, sorry. You can just plug this in, pop, pop, and it just keeps going like this. Now, we also have a new term to define. We usually call it goods and services, but what about bad? It's like a villain, right? So a bad is actually, well, it's a product or something that is preferred less to more. For example, pollution or trash or garbage or anything bad in this world, or like even crime maybe or something, I don't know. So those are all bads. Consumers will prefer them less. They would like less of them, not more of them. Now, in a subject all about graphs, all about being specific, how would that impact our curves? Actually, it would impact our curves really badly. We'd have to make new curves. We'd have to account for bads, which is just something we don't want to do. So instead, what we do is we have to redefine and handle a baddie. It's called a bad, but I just call it a baddie because, you know, Gen Z humor. So first, we actually redefine the bad. For example, if you had air pollution, of course, you'd want less air pollution in the world. And then instead of having a convex curve, you'd have a concave curve or something like that. So you don't want to change the entire graph over just one good. So instead, we redefine the good. So instead of calling it air pollution, we'll call it clean air. And clean air is desirable. So we'll just turn the bad into a good, into a desirable good. Of course, we'd want more clean air, not less clean air. And, you know, instead of having to flip the entire curve and change everything, we can just, you know, instead of just change the subject, just change the topic. And of course, buy her flowers. This is a shout out to Althea Haldor specifically. Good luck getting a girlfriend, bro. Now I have actually a bunch. I think I have 6 different graphs that are not labeled correctly, by the way. In the exam, do not label them of H and S. Write the full thing down. If it's called hamburgers, write hamburgers. If it's called soft drinks, write soft drinks. I am an exception because I am your teacher, and more importantly, because I am lazy. Now, let's say Mirza likes hamburgers and likes soft drinks. How would the curve look? Okay, I'm not going to give you time to answer it. The curve would be the same, convex to the origin. Like this dude would look like this. Same as always, because both goods are desirable, that's why it's falling, and it also shows you the opportunity cost, because if he has more hamburgers, then he has to substitute less soft drinks. So that's Mirza's thing. I'm going to call it M. Now, what about Ethan? Ethan doesn't like soft drinks. He likes hamburgers. Okay, that means that soft drinks are a bad because we don't like soft drinks. So that would mean you have to mirror it. Instead of it being like this, it'll be mirrored in the x-axis because soft drinks are in the x-axis. Now it'll look like this. So, since soft drinks are bad, the more soft drinks you have, the more hamburgers Ethan needs to eat to compensate and have the same level of utility. He doesn't like soft drinks. So if he had 10 soft drinks, which by the way he wouldn't want to end out, so I think he would die. So he needs like 20 hamburgers, 30 hamburgers or something just to be the same level of satisfied. Okay. Now, what if, let's just say, Arindam Shukla right? These are hamburgers, and I'm assuming hamburgers have some kind of meat in them. And this guy is veg. So he does not have any hamburgers, but he has soft drinks. And for some reason, he only gets the sugar one, not the zero sugar. So that would mean it's perfectly elastic. Now, you might be asking me, wait, why? Why isn't it like this? Why isn't it perfectly inelastic? Well, the thing is, Arindam will not eat more hamburgers. He does not like hamburgers at all. So that means that, let's just say he has 2 hamburgers, right? That means that if he had a 3rd one, a 4th one, a 5th one, first of all, he wouldn't have it. And second of all, it would provide negative utility. It wouldn't be good for him, which is why it's perfectly elastic. Now, if he has more, sodas or soft drinks, he loves soft drinks, so it'll keep going like this. Now, in the same case, if, let's just say, Ash&Milk, all right, there's soft drinks and then there's hamburgers. He loves hamburgers, but he hates soft drinks. He does not drink any soft drinks. He won't drink anything, actually. So if you gave him more soft drinks, well, he wouldn't drink it. If you gave him less, it wouldn't impact the utility. But if you gave him less soft drinks, that would be a different curve altogether. So that means that the more hamburgers you give him, the more utility he'll get. Okay, cool. Now, what if we had a man really healthy and he does not like hamburgers or soft drinks, like Aryaman Kumar, who eats healthy every single time? Okay, that would mean that, okay, wait, hold on, I need to remember this curve, 1 second. We don't like hamburgers and we don't like soft drinks. So that would mean that it's a reflection in both of the axes. Shit, how do I draw this? It would look like this. It would look like a PPC curve. Like this. That is how it should look because Aryaman hates hamburgers and he hates soft drinks. So the reason why it looks like a PPC and it's going like downward is because both goods are bad. They're both bad. He doesn't like hamburgers. He doesn't like soft drinks. He would prefer less to more, of course, which is why it goes. Looks like that's why it's concave, like up to the origin, like this. Okay, cool. And now, what if you didn't like anything at all? What if you hated hamburgers and hated soft drinks? It wouldn't exist. That's a trick question, obviously. But seriously though, what if you if you had 2 hamburgers, you'd have to have 1 soft drink. Just like that. Let's just say you're Sai, for example. Sai is very specific about his food. So, if you had 2 hamburgers, you'd always have to have a soft drink. Okay, well, we could always write down the numbers. Okay, so 2 hamburgers, 1 soft drink, 4 hamburgers, 2 soft drinks. But I'm a little lazy. It would look like perfect complements like this. See? It will look like this. Because since they're proportionate always, it will resemble perfect complements. That means that if he has 4 hamburgers with only 1 soda, it does not really impact his utility. And if he had more sodas, but the same amount of hamburgers, it will not impact his utility. He demands them at different portions. That's it. So, okay, enough for the jokes for real though. But, now we have to talk about ordinary and cardinal utility. So, ordinal utility is essentially a ranking. Consumers rank the goods. They don't tell you by how much is one good better than another. For example, Maria and James. Now, Maria, let's just say, has utility of 10, and James has utility of 5. Ordinary utility, by the way. Okay, what does that mean? Do you think Maria is 2 times happier than James? No, she is not 2 times happier than James because they are just arbitrary labels. They're just numbers. They're just rankings. They don't show you by how much is one person happier than another compared to cardinal. Cardinal utility compares the goods and it tells you by how much does one prefer another. For example, in this case, hamburgers are 10, sodas are 5. That means that hamburgers provide double the utility as sodas do to a person. Okay, but now you think, hey, that's really specific. That's good for economics, right? Because it provides more structure, more clarity. Wrong. So the reason is, in economics, right, we assume a lot. Why do you think we assume? Do you think we know everything? Of course. That's the reason why we assume. So in economics, we have imperfect knowledge. We don't know everyone's utility. We don't know what people like always. We don't have perfect information. So we're forced to make these assumptions. Because first of all, if we didn't make these assumptions, then there'd be so much human error that economics wouldn't even be classified as science. It would just be considered a pseudoscience probably. And then second of all, it's just impossible to know everything. So no one's going to track all that. No one's going to ask you, hey, if you had to get, 2 fitness backpacks or 1 backpack, how much would you like it? And people they wouldn't even be able to talk. It'd be like, what? What the hell is this guy saying? Get this joker out of here. That's what they would say. So essentially, cardinal utility, it is good, it is specific, but it's just not necessary. Because when you already have the ordinal utility, you already know, using the consumer assumptions last time, that their decisions are rational. That means that hey, okay, so they prefer one over another. So then by doing this, we can already assume, and we already know how customers will behave and react, and we already know demand. We can already assume the demand curve. We don't need to know the exact, utility or benefit that each customer gets. Each customer gets in a market of customers, by the way, from a specific good. It doesn't do anything. So in economics, I'm mixing these words up, sorry. Economists ignore the cardinal value. While yes, it's good, it cannot be used in reality, sadly, and it's just a theory, a game theory. Thanks for watching. Also, I want to say that this is a pretty nice subject, pretty good course, and it's going pretty well. What I do now, I played Roblox with Ralph Edson. That was pretty fun. And, I went grocery shopping, so that was also pretty good. Why am I including this in the video? I just want to share a bit of my life to you, buddy. Just want to share a bit of my life. Watch my other faith videos too, by the way. Don't just watch the economic videos. Because a man cannot live on bread alone. Who said that? Jesus said that. Practice your faith, read your Bible. Bye.